Wow, Will, this is a great toy.
Yes, but I wonder why the cat never catches the mouse.
Hello there. I can tell you why.
Who are you?
I am Magnus. And the answer to your question lies in magnets. In this lesson, we will talk about the discovery of the magnet and about magnetic and non-magnetic materials. At the end of this lesson, you will be able to describe how magnets were discovered and differentiate between magnetic and non-magnetic materials.
But what have magnets got to do with my toy?
The cat is not able to catch the mouse because of magnets. If you were to take the toy cat apart, you would find a magnet placed in the mouth of the cat. This is repelled by another magnet placed inside the tail of the mouse.
Oh, I would have never guessed that.
So, how do you know so much about magnets?
Well, actually, I discovered the magnet. Would you like to hear the story of how I discovered magnets?
Yes.
Great. Follow me. We will go back in time to around 2000 BC. I come from Magnesia in northern Greece. It was a beautiful place with mountains and rivers. Being a shepherd, I used to take my sheep out for grazing on the mountains every day. Have you ever tried to graze sheep?
No.
Well, it's a tough job. The sheep never go where you want them to go. So I used to carry this wooden staff to guard and direct the sheep. See, it has a small metal piece at the end. One day, when I climbed onto a large black rock to take a look at all my sheep, I found that my shoes that had iron nails got stuck to the rock. Even my staff was sticking to the rock.
Did you check whether it was happening with other rocks as well?
I did. I first tried to pull and tug myself free from the rock, and then I tried touching different rocks around me with my staff. Come, why don't you try for yourself?
This one does make the staff stick.
But this one doesn't.
I see that both of you are trying to touch each rock only with the metal end of the staff. It took me some time to figure out that only the metal piece at the end of my staff was sticking to the rocks. I was both scared and confused. I dug up the rock and accidentally discovered a
magnet.
Well, you are smarter than me. I did not even know that I had discovered a magnet. I took the rock home. My friends and family told me that it was a magical rock. Some even thought that it was evil. People try to do many strange things using its magical powers, such as heal the sick and even frighten away evil spirits. It was much later that I came to know that what I had discovered was a natural magnet.
Natural magnets? Aren't all magnets natural? I have only heard about magnets.
Natural magnets are rocks that occur in nature and have the magnetic property of attracting materials like iron. Present-day magnets are mostly man-made. These are called artificial magnets.
How do you know that?
I discovered magnets, so I have always kept myself updated on the latest news on them.
I don't think people today see the magnet the same way they used to when you discovered it.
Yes, you're right. Magnets have evolved so much over time. But it's getting late. We can't stay in the past for too long. Let's go back home now. You can get back to your game. But you do realize now where the word magnet comes from.
I get it. Magnets are named after you.
Well, you're right in a way. The name magnetite has been derived from magnesia or Magnus, and magnets are named after magnetite. Did you know? The natural magnetic rock that Magnus discovered is called a lodestone. Lodestone contains a natural magnetic material, a compound of iron called magnetite. In the form of a bar, it was used to find the directions on Earth. Hence, it is called a lodestone, meaning a stone that leads. I used to go around touching all objects with the rock that I had found, thinking that everything will stick to its surface. Let's meet Will and Anne again.
So why don't all objects get attracted to a magnet?
Only some selected materials are attracted by a magnet. You will find lots of non-magnetic materials around. Basically, the materials that are not attracted by a magnet are known as non-magnetic materials. Similarly, the materials that are attracted by a magnet are known as magnetic materials. In fact, objects made of metals such as iron, cobalt, and nickel are magnetic.
Then why aren't these coins sticking to the magnet?
That is because modern coins are made of a uniform mixture of different metals. Therefore, they become non-magnetic.
Got that.
It's fun playing with magnets.
Yes, it is. In fact, for many years, people have been using the magnetic property of objects in various ways. For instance, not many people know that the ancient Greek scientist Archimedes of Eureka fame is believed to have used lodestone to pull nails from enemy ships. Taking the nails out made the ship sink.
Wow, that's imaginative. I would never have thought of it.
This brings us to the end of this lesson on the discovery of the magnet and about magnetic and non-magnetic materials. In this lesson, you learn to describe how magnets were discovered and differentiate between magnetic and non-magnetic materials.
Just see what happens as soon as I leave this magnet alone here. Have fun.
Hey, good to see a new face. It was getting lonely here. I'm Bruno.
Hey yourself. I'm Fred. Phew. Long journey.
How can you stick on the fridge like that? I can't do that.
Oh. That's because I'm a magnet. And you are an iron piece. Magnets are substances that possess the property of attracting iron. But iron doesn't have that property. But how did you land up here?
Oh, I'm a building block from a game that Sam, my master, plays. Right now, He's out playing with friends. So, where are you from?
I was born in Mexico. I had such a wonderful life. Those were the good old days. I was a fine young magnet then. Me and my friends, we were really proud of our poles. Oh, the fun we had in attracting iron filings.
Poles? Never heard of them. What are you talking about? And you can attract iron? Does that mean you can attract me too?
Sure he can. But he'd have to get off the fridge to do that.
Let's see what Fred is talking about. In this lesson, we will learn about the properties of a magnet and its uses. At the end of this lesson, you will be able to demonstrate the existence of poles in a magnet, explain how magnets are used to find direction, and explain how to make and protect a magnet.
And who are you?
I'm Andy, the Bob Magnet from the toolbox. Nice to meet you, Fred.
Hey, Andy. Nice meeting you. Why don't you come out for a bit? Bruno is asking me about poles. Maybe you can answer his questions.
That's no big deal. The two regions at the ends of a magnet are called its poles. All magnets have poles. I have 2 poles too.
Using my poles, I can get an iron piece like you to stick to me, Bruno. Just watch.
Whoa, I believe you. I feel like I'm being dragged towards you. Looks like I need to be careful of your poles.
Actually, we can attract objects from other parts of our bodies as well. However, the poles have higher magnetic power and hence attract objects more strongly.
Let's leave our friends here for a moment and examine the poles of a magnet more closely. You can see here that the poles of a magnet are the 2 regions at its ends.
That's interesting. So, you have 2 poles at the ends of your body?
Sure, see? This end is called the North Pole, and the other end is the South Pole.
But how can you tell which pole is north and which one is south? The poles look the same to me, except for the fact that one is painted blue and the other red.
Exactly, Bruno. Human beings use colors to distinguish the North and South poles. The North Pole is usually painted red, and the South Pole is usually painted blue. But this is not always the case. You will find a large variety of magnets.
Let's see the different ways in which the poles can be shown on magnets. Sometimes half of a magnet is painted in red to indicate the North Pole. The South Pole is left unpainted. Magnets used in laboratories are generally painted completely red in color with a white dot to indicate the North Pole. Thus, typically man-made magnets generally have some indicator to identify the North Pole. The other pole can then be automatically identified as the South Pole.
Magnets are also found in different shapes and sizes. You have already seen how different Fred and I look. Let me show you pictures of some of my friends. This is my friend Cylindro, the cylindrical magnet. The poles in a cylindrical magnet are at the 2 circular ends of the cylinder. This is Mr. Dumbbell. See those 2 dumbbell-shaped ends? That's where his poles are.
Oh, so the poles in a dumbbell-shaped magnet are at the two dumbbell-shaped ends.
And this is my best friend Horsey, the horseshoe-shaped magnet. The poles in a horseshoe magnet are at the two free ends of the U-shaped ends.
So, the magnetic power of Horsey will be focused on these two ends of the horseshoe?
Right. You be careful not to go near these ends if you meet him.
You have nice friends. But do magnets always have both the north and south poles?
Let me answer that. Yes, Bruno. A magnet will always have both the North Pole and the South Pole. A magnet with a single pole does not exist.
In the workshop where I was born, I saw magnets being cut to make toys. Won't those magnets lose one pole when cut into half?
That's one of the interesting things about magnets. Cutting a magnet into two pieces will give you two magnets, with each of them having both north and south poles.
Did you know? A magnet is called a dipole because it always has two poles.
So, where are you from exactly, Andy?
I am from El Paso, in the northern part of Mexico.
Mexico? Wonder where that is.
Well, I heard my master say it is towards the south of the United States of America.
I'm not sure which way south is.
I just hang loose when I want to figure out directions.
That's a good strategy. Bruno, magnets always point in the north-south direction when they hang loose. That's why, in earlier days, travelers always carried magnets with them to find their way. Whenever they needed to figure out directions, they suspended a magnet by a thread and observed the direction it pointed to. I'm sure many of our ancestors saw a lot of exciting places as they traveled with their masters.
Yes, it must have been fun. Even today, magnets and compasses get to travel a lot.
You magnets lead exciting lives. Now, what is this compass?
A compass is an instrument used to find directions. It has a thin magnetic needle that can rotate freely inside a brass box. There is a dial inside the box with the directions marked on it. The box has a glass cover so you can observe the movements of the needle inside.
But how does a compass tell you about directions?
I'm sure you, like Bruno, are also curious to know how a magnetic compass functions. Let me explain. The poles of a freely suspended magnet always align in the north-south direction of the Earth. Since the compass needle is a magnet, its movements are based on the properties of magnets. Thus, it always points along the north-south direction. The tip of the magnetic needle in a compass is painted red, and it always points towards the north direction of the Earth. Notice this compass. The magnetic needle comes to rest and points towards a specific direction. This is north. Now rotate the compass box such that the red tip of the magnetic needle coincides with the north mark on the dial. This shows the correct direction of the location of an object. Now you can use this compass to determine the direction in which objects around it are located. For example, you can see that the fridge is in the north direction, the table is in the northwest direction, and you yourself are standing in the southern part of this room.
What are you thinking, Bruno?
Sorry. Can you prove that a magnet can point in the north-south direction when it is hung loose?
Looks like our friend Bruno has some doubts on the capability of a magnet. Let us clear his doubts. We know that the sun rises in the east. Since it's early in the morning, by looking at the rising sun, we can determine which direction is east. We'll tie a thread to a bar magnet and suspend it freely from a stand. Let us also place a magnetic compass beside the stand. You see that the sun is facing us, so that is east. If we are facing east, west is behind us and north is to our left. Now watch the bar magnet's movements. There, it's come to rest. Do you notice the direction it is pointing towards? Its poles are pointing in the north-south direction. Take a look at the compass needle now. It also points in the north-south direction.
Did you watch that experiment, Bruno? Now, do you believe us?
Yes, convinced. I can see what you mean now. Magnets have some interesting properties.
That's not all though. In all magnets, like poles repel and unlike poles attract each other. That is, the north and south poles attract each other, while north pole repels north pole. Similarly, the south pole will repel the south pole of another magnet.
Repelling is the opposite of attracting, right?
Right. Attraction means being drawn towards each other, and repulsion means moving away from each other.
You should see the fun my sisters and brothers have at the